Okay, now for this question then, we've got to find the equation of the normal to this curve at the point where x is 2. And we're told that x cannot equal 5/3. And that's because obviously if x was 5/3 and you substituted it into this denominator here, you'd have 0. And 3 divided by 0 is an undefined value. So how are we going to find the equation of the normal then at the point where x is 2? Well, just as a little bit of background and just to appreciate the problem, what I'm going to do is just think of a sketch here. Now, you don't have to necessarily draw the sketch of the graph, okay, to really appreciate what's going on. You've got a curve, say, okay, let's just suppose we've got a curve something like this. And this is our curve C. And we've got a point on this curve where, say, x is 2. Let's just mark that in there, 2. 2 something or other. We don't know what the corresponding y coordinate is. But we want to find the equation of the normal at this point then. Well, a normal then is always perpendicular to any tangent. So if that blue line is the tangent at this point, then the normal will be a line looking something like this. Okay, perpendicular to it, right angles. And any straight line has the form y minus y1 equals m bracket x minus x1. It's better to use this than y equals mx plus c, I often find. So when it comes to working out what the equation of the normal is, what I need is my y1 value. I've got my x1 value, it's the 2, the point on the curve. So I can get that very easily by substituting x equals 2 into here. So let's start by doing that first of all, by saying when x is 2. When x equals 2, what's the corresponding y value going to be? Well, it's a simple substitution then. It's just going to be 3 divided by 5 minus, well, 3 2's are 6, 5 minus 6 is minus 1, square minus 1 and you've got 1, so it's 3 over 1, or in other words 3. So I could update this diagram. This point here has coordinates 2, 3. Okay? So I've got my x1, got my y1, I need to get m, the gradient of the normal. To get that, I need to get the gradient of the tangent at this point, but I need to get the gradient at any point, and that's got by differentiating y with respect to x. Now to differentiate this, I can see quite a few people thinking, oh, they'll use the quotient rule. And you can if you want, but I certainly would encourage you to do that, because you'd only really want to use the quotient rule when you've got two functions of x on the top and the bottom respectively. Okay, and here we've just got a constant. It doesn't say something like 3x. Okay, so I wouldn't really encourage you to use the quotient rule. What I would want to do is rearrange this to 3 multiplied by 5 minus 3x to the power minus 2. Remember, this is 3 times 1 over 5 minus 3x to the power 2. So you can bring that up and write it to the power minus 2. And when it's in this format, we can use the chain rule. And hopefully you're familiar with the chain rule. If not, I'll just give you a quick bit of background to that. Okay, when it comes to differentiating this using the chain rule, we'll just have a line down here. If you want to find dy by dx, it's the same as dy by d something multiplied by the same d something over dx. It's as if these two values cancel out. Okay, it's not strictly true, but it's as if they do. And we can introduce any dummy variable we like here, d by d something, and I'm going to choose d by dt. Alright, you might see though some teachers and authors use du, okay, for this, but I always go for dt. So in other words, what I'm going to have is that I'm going to let t equal the 5 minus 3x. Okay, 5 minus 3x. So that means that y equals 3t to the minus 2. So therefore y equals 3t to the minus 2. So this is the chain rule idea. Okay, we'll just kind of separate that. We'll box it off there. Now then, so when it comes to differentiating this dy dx, okay, we've got to do dy by dt first of all. So to differentiate y equals 3t to the minus 2, with respect to t, it's minus 6t to the minus 3. Minus 6 then, t being 5 minus 3x to the power minus 3. So that part then is dy by dt. Now we've got to multiply it by dt dx. We need to differentiate t with respect to x. And if we differentiate t with respect to x, well, 5 goes to 0 and minus 3x goes to minus 3. I wouldn't write a multiply sign there. I would just encourage you to use brackets. So minus 3. Clean this up and you've got minus 6 times minus 3, which is plus 18, or just simply 18, and this is multiplied by 1 over 5 minus 3x to the power 3, which is going to end up being 18 over 5 minus 3x all to the power 3. Okay, I certainly wouldn't leave it as a negative power. Much better to have these as positive powers. So this gives us the gradient of the tangent at any point on the curve C. But we're looking at the gradient of the tangent at a particular point, x equals 2. So I would want to say that when x equals 2, find out what that gradient is. Find out what dy by dx is. So, what is dy by dx then, when x is 2? We'll substitute in here. We got 3 2's are 6, 5 take away 6 is minus 1, minus 1 cubed is minus 1, and so 18 over minus 1 is minus 18. So we've got the gradient of the tangent here, minus 18. We want though the gradient of the normal, the m value in here. And you should remember that the gradients are related. If you multiply the gradients of two perpendicular lines, it comes to minus 1. So therefore the gradient of the normal, so we just write that in, gradient of normal, okay, is going to equal 1/18. Okay, or a simple rule, all you got to do is switch the sign, minus to a plus, and reciprocate the 18. Okay, so that'd be 1 over 18. So that's the gradient of the normal. So we've got everything we need now to get the equation of the normal. So therefore we can just come down here, tell the reader what we're doing by just saying therefore equation of the normal is, okay, equation of normal is. Do try and avoid writing an equals there, okay, as I've said many times in the past. Okay, equation of normal is, and then it's going to be y minus y1, which is the 3, equals m, the gradient of the normal, which is 1/18, multiplied by x minus x1, so that's x minus the 2. Now we need to get it in the form ax plus by plus c equals 0. That's what we're told in the question. So to do something like this, I would want to get rid of the 18 by multiplying throughout both sides by 18. So therefore we'd have 18 times the y, 18y, 18 times the minus 3, which is minus 54. And when it comes to multiplying this one term by 18, well, look, the 18 will cancel and just leave me with 1 times the bracket. So expanding that just gives me x minus 2. Now I'd want to subtract 18y and add 54 to both sides. And if I do that, I'm left with x minus 18y, and then I've got plus 54 minus 2, which is going to be plus 52, and that equals 0. So that's in the form ax plus by plus c equals 0, where the a B and C would be integers, okay? A being the 1, B being the minus 18, C being the 52, if we were ever asked, okay? So hopefully that's given you a bit of background to doing this question, okay?